Okay, just a few things I want to go ahead and make sure that you're aware of. This weekend you do have a 3-day weekend. Okay, the teachers in the district have to go to a content focus session on Monday, which means we're going to, oh, hello. Oh, hey, all done? Thank you. Okay, so we're going to get together and collaborate on our lessons, talk about things that we need to take care of. So you guys get the day off, so that's going to be super awesome for you guys. I got to get out of bed and go to work. It's going to be sad. Anybody got to set their alarm just to wake up and think, hey, Mr. West is going to work. I'm going to go back to sleep. Okay. Anyways, but it's going to make next week, kind of unusual because you have a 3-day weekend, because the big item next week is going to be the test. We're already halfway through the second 6 weeks, therefore halfway through the semester. So it's not going to be long before, we're already leaving for Christmas break. Okay, we got 9 weeks. So the exam's going to be next week. We should be able to get through implication and equivalence, which is the next lesson. Will most likely have begun probability, but I don't think it's going to be a part of the test. I would be looking for the test to cover the homework that we just had, truth tables, and then the next lesson that's coming up. All right, so we want to be looking ahead to that. We have another quiz coming up this Thursday on the 18th, so 3 days from now. It's going to be over the homework that we just turned in, okay, our introduction to sets. That does not apply to you. That is pre-calculus. So I'm thinking, depending on if we're able to finish today, I might just go ahead and pass the homework out at the end, or I may just go ahead and pass it out tomorrow. I'll kind of see how things go by the end. But that's all I have right now, unless anybody has any questions. Hey, Gabby. The second exam will cover everything from intro to sets through implication and equivalence. And part of that lesson, you guys may remember from other math classes, we'll talk about converse, inverse, contrapositive. Do those kind of sound familiar? Okay, if they do, great. If not, we're going to talk about those. All right, so just a quick recap. Let's see here. A proposition, that's a statement that is either true or false, never a question, never a command. We kind of talked about that. And what we spent a lot of the time doing so far is relating all these ideas from sets to logic and truth tables. Okay, so let's go ahead and run through a couple of these very quickly. All right, let's say we have our propositions P and Q. So if I have P here, P and Q, so this would be true, false. Let's talk about the negation. Okay, and actually I should probably change that. Q wouldn't be a part of that. Okay, it will in the other truth tables. But the negation is just to go ahead and verbally put in, say, not, do not. So if it starts off being true, it's what? The negation is false. If it starts off being false, the negation is going to be true. Okay, and like I said, we use the sideways L to kind of use that as our notation. We've also used the little curvy line, what we might call a tilde, for similarity in geometry. All right. And then we talked about something called a conjunction. Okay, what was that related to? Not to union. Intersection. Okay, so a conjunction was an intersection. Remember, we're looking for the values or the items that they share. So if I were to have, P and Q, we'd have true, true, false, false. Now, we've been seeing, whoop, this thing is not letting me write today. The intersection is that capital upside down U, but there was a new notation we introduced with it. This, and what was it? The upside down V. Okay. Okay, so let's go ahead and fill in the truth table for this. So let's say I want P and Q. I don't know why I keep doing this. Hang on. What am I messing up on? Oh, that's right. Okay. Sorry. It's a Monday. Okay, so this would be true, false, true, false. And we'll talk about the layout of the truth table in just a second. But does anybody remember how this has to work? Because it's P and Q. How do I know when this is true? How do I know when it's actually going to be false?
If it's an intersect, it's one or the other, right?
You're correct if it's a union, one or the other. But if it's an intersection, if it's and, in order to be true, Both must be true at the same time. So this one right here is going to be true. What about true, false? False. False, true? False and false, false. False. Okay, so an intersection has to have both true at the same time. All right. Then from that, we went on to what was called a disjunction. Now, if the conjunction is an intersection, the disjunction is a union. Okay, so let me go ahead and replace these symbols right here. So we've been seeing the union as just the normal U. Why is it not allowing me to draw? Here, I'm just going to do this. There you go. Q. Okay, and we also saw the other day the new notation, just a normal capital V. Okay. Now, Eli is absolutely correct in his definition when we're talking about the union. It's one or the other or both. Now, there was a difference. If I don't have the bar here, was that inclusive or exclusive? That's inclusive. So the inclusive states one or the other or both. So as long as at least one of them is true, you're going to have a true statement. So true, true would be true. True, false. True, false, true. And false, false. In fact, that's the only one that's false for a disjunction. Okay. But now there was one, and this is what we were thinking of. If you have the V with a line below it, that's the exclusive. So while this one was one or the other or both, this one was one or the other, but not both. Okay. The exclusive cannot have both true at the same time. The inclusive can. Okay, so let me go ahead and put in, okay, this symbol right here. So the exclusive union. So true, true would be what? False. There we go. One or the other, but not both. So this one would be false. What about true, false? True, false, true. True, false, false. False. Okay, there we go. Right. Is everybody okay with those? Okay. Well, all right, good. I think that's pretty much as far as we got. I think didn't we start a problem? Yeah, so we did those. We talked about those. Okay, and we set this one up, but we just have not finished it yet. Okay, so this is where we got to on Friday. All right, so let me find my appropriate place in notes. All right, so the universe is the set of all counting numbers from 0 to 50. Okay, so my first proposition, Px is an odd number between 0 and 20, so we went ahead and listed those. And then Q, the second proposition, x is a factor of 45. And we've got those 6 factors right there. So for A through D, okay, we want to go ahead and write a statement for the compound proposition. And we've already talked about the capital upside down V. Remember, that was an intersection. So we could probably say something like, x is an odd number. Now I'm going to go ahead and put a pound somewhere, number. Okay. Well, I lost my place. Between 0 and 20. And if you go ahead and put B/T, that's just like an abbreviation for between, just so I don't have to write it out. Between 0, that's a weird T, and 20, what? And is probably say is a factor or a factor of 45. And is a factor of 45. There we go. And I mean, you can go ahead and repeat, X is. I mean, I don't think it's necessary, like when you're writing sentences, just keep using that noun over and over again. Okay, but if it sounds good to you, absolutely go ahead and do that. All right, so let's go ahead and fill in this truth table, what we were just trying. In fact, take 15 seconds, fill in this truth table. Now remember, and think about what definition we gave just a few moments ago. Okay, this is the intersection. Okay, now what does it mean, intersection again? At least what? If it's going to be a true statement. At least one of them has to be true. So is this okay for both of them to be true? Yes. What if only one is true? Ooh. Did I say at least?
Yeah.
I'm sorry about that. I'm thinking about the union already. Okay, no, they both have to be true in order to be true. If one of them's true, it can't work. It's one and the other. So you should have true, false, false, false. Both have to be true in order to get a true statement when you're dealing with an intersection, a conjunction. That's my fault. Sorry about that. Okay. And then on a Venn diagram, we've seen this several times. The intersection would be their overlap. This right here in the middle. Okay. And then I don't have it on the screen here, but part D lists the elements in the truth set of the compound proposition. So if I'm looking at sets P and Q, well, what do they both share? 1, 3, 5, 9, and 15. 1, 3, 5, 9, and 15. Okay. Now, the thing about truth tables is they're progressive. You're going to want to have a column for every little part of an expression that you have. So let me kind of show you what's coming up. Let me show you some of these right here. Now, you'll notice eventually we're going to create a truth table for this one. In fact, it's going to be our next problem, right? Well, you'll notice all the individual elements that make it up, you're going to want a column specifically for that one. You see, we've got 3 here. So PQR, well, that's exactly how we're starting, right? Okay. Well, you've got not this quantity. So you have that. You also have the quantity itself. So you see, it builds up with every individual piece and quantity that you have. Okay. Same thing down here. Okay, I'm going to show you that one in just a second. Oh, look away. I forgot to erase that one. Okay. But here you go. You see, this is only made up of propositions P and Q, so I start with P and Q. We need a not P and a not Q column. We need a quantity for P and Q. We need a quantity for not P and not Q so that I could eventually get the entire statement. It does build upon itself. Is everybody kind of seeing what I'm trying to say there? Because I'm very articulate today, obviously. Okay. But anyways, so this one here, if we're trying to show P or not Q, we would probably want to add a what? What would be another column that would be very useful to me? Not Q. Okay. That's exactly right. Okay. Now, I'll go ahead and ask you, did you guys want to try this one on your own? Did you want to work it together? We should work together? All right, let's do it. So the negation is just going to change a true to a false and vice versa, right? So what should this last column be right here? Should be false, true, false, true. All I did was take the statements in Q and I just negated them. Is everybody okay with that? It's easy, right? And also, it's really a good idea to go ahead and do this because, see, now I want to go ahead and take, let me erase this other one here. And I kind of skipped the statement. We'll go back to it in just a second. But see, now I want P or not Q. Okay. Oh, I am on the ball today. So see, I can just go ahead and do a comparison of those two columns with my definition of the union. Okay. So let me go ahead and highlight this. Maybe it'll be better than just drawing an arch. Highlighter. So I want to use this one and this one that we just came up with. Okay. Now, is this the inclusive or exclusive? This is the inclusive. So what does that mean? Okay, both can be true, or just one of them can be true. So see, for P or not Q, I'm comparing these right here. So for example, a true false would give me what? That would be a true. Because I know by definition the inclusive union can be one or the other or both. Yes. Okay. What about true, true? That would be true. What about false, false? Yeah, that's false. Now remember, that's why I highlighted these. Okay. And what about false, true? That's true. There we go. Yes. See, I'm only comparing the columns that this guy is wanting me to. So that's why I went ahead and highlighted those and I drew the arch. And that's why it's always a really good idea that you build up from the base elements of these expressions, because then you can just look at those directly. Yes? Yes, because see, in this final statement right here, we wanted the negation of Q or P. So we added on this other column, the not Q, so that I could easily do that. I'm sorry? Oh, the not Q was part of the statement that we wanted to show. Oh, you mean this last column right here?
Yeah.
Oh, we just changed the true-false statements from Q. So like, for example, if we started true, then the negation would be false, and vice versa. Okay. What can we say as far as a statement here, as far as A goes? Like, what does proposition P say? Okay, so X is an odd number between 0 and 20. What? Or is not a factor of 45. Or is not a factor of 45. Yes, there we go. Perfect, perfect, perfect. Okay. Well, let's go ahead and try this one right here. What would the shading look like? I mean, just think, again, if it's kind of difficult, relate it back to what we've talked about with sets. Not Q, wouldn't that be the same as Q prime, that Q complement, right? So for the shading, think about everything outside of group Q, but I want to take the union of that with P. So it'd be what, Gabby? Okay, so Gabby says the crescent and the universe. Would you agree? Okay. Now that's a good question. Maybe go ahead and shade the middle part. Because we're the complement of Q, so I want everything outside of Q merged with P. Okay.
But it's the union of the two.
Yep. So what do you guys think? Okay, so we got, he's very, what's the word I'm looking for? He's confident. I like that. There we go. He's very confident. Okay, Emily, what do you think? Okay, now by definition, it's everything outside of that given set. Okay. What do you think? Okay. It would be to include it. Now you're right. Look at them individually. Okay. Look at them individually. I've got P and I've got Q. And then over here I've got another universe with the same groups. P and Q. Well, let's just say, we want P. Okay. So that would be everything here. But then I want Q complement. So that's everything outside, right? But see, we're wanting to take the union of it. So everything I see here combined with everything I see here. So it's true, yes, it would include the intersection, yes. Is everybody okay with that? And that's how, when I first started learning these, it always helped me. If there's ever, a question like that, draw them separately. For me, that really helps out. I don't know. It seems a little sketchy, but. Okay. Anyways. All right, so basically what I'm looking for here based on this statement is everything in the universe except for what's solely in Q. So D is where I'm actually going to go ahead and write out what that set is. Okay. So are there any elements just in U that don't belong to P? Well, let's see. 1, 3, 5, 9, 15. All of those belong to P, right? So according to this, I mean, it's still going to be part of the solution set. So I would probably say something along the lines of the set is all X. It is a counting number from except 45. Okay. 45 would be the only one by itself, which is strictly Q. Does that make sense? Okay, well, I'll go ahead and write it out. Okay. So, well, I guess I can write it out. Yeah, let's do that. X is the set of all numbers between 0 and 50, okay, but not 45. So basically, if you were to go ahead and draw the entire set, it would be 1, 2, 3, 4, 5, 6, 7, 8. It would have every number except 45. That's why I kind of hesitated, because I was like, I really don't want to write all those numbers. There's no sense in that. Hey, Tiana. Okay. Here we go. Okay, how are we doing? Okay. Yes. You know, if I were going to go into set notation, I would probably say all X such that since we have the universe, I would say X belongs to the universe. X can't equal 45. I'll probably do something like that. Is everybody okay with that? D is asking for the actual set, yeah. So realistically, I mean, we should actually write out 1, 2, 3, 4, 5, all the way to 50, except not put 45. But that's too many numbers to write. We don't want to do that. Or maybe we do, I don't know. Yeah, that's probably the better way to do it with the solution set. Okay. How we doing? Okay. All right. Well, now let's actually get right down to it. This is where we have the fun. I like doing this stuff. Okay, create a truth table for not the quantity of P and Q or R. Okay, so you'll notice, again, we have PQR. We've got the quantity intersection. We've got the negation of that. And then we have that negation quantity with R. Yes? No, in this case, the not is only going to apply to that quantity. Okay. All right. And there was something I think I accidentally skipped when I was in the middle of the lessons. However many propositions you have, okay, you can always go ahead and use that as a power for base 2. Like, for example, in these previous problems, okay, you see how we always had 4 rows? Well, we've only got 2 propositions, right? So I'm always going to use base 2, but to 2 propositions, well, that would give me 4 rows. Okay. But when we're talking on this one, how many propositions do I have? I have 3. So you always use base 2 with the power of the number of compositions. So this is why I have 8 rows. So if I were to be comparing 4 propositions, how many rows would my table have? 2 to the 4th. There would be 16 rows. Okay. So the table is exponential based on the number of propositions that you have. Okay. So let's see here. Oh, is it already 2:04? Time flies when you're having fun, right? Yeah. Okay. Well, hold on. Let me ask you guys. I already think I know some of your answers. Should we try to go ahead and get this done, or should we wait till tomorrow?
Let's not rush.
Okay. Okay, we'll stop. And then that actually works out better because we only have this last page. We go ahead, finish this up, and then tomorrow you can have the rest of the time to work on your assignment. There you go. Sounds good.